Next we are going to learn about the error reporting messages used in ICMP. There are different types of error reporting messages. You can see here. First one is type 3, which is known as destination unreachable. Type 4 is known as source quench. Type 11 is known as time exceeded. Type 12 is known as parameter problems. Type 5 is known as redirection. First, let us see destination unreachable. The message of destination unreachable is passed to the sender when the receiver could not be contacted or the packet was discarded because the ultimate destination could not be contacted. എപ്പോഴാണോ ഒരു പാക്കറ്റ് ഡെസ്റ്റിനേഷനെ റീച്ച് ആവാതെ പോകുന്നത്, റിസീവറിനെ ഡെസ്റ്റിനേഷനെ കോണ്ടാക്ട് ചെയ്യാൻ പറ്റാത്തത്, അല്ലെങ്കിൽ പാക്കറ്റ് ഡിസ്കാർഡ് ചെയ്യുന്ന എപ്പോഴായിരിക്കും? ഡെസ്റ്റിനേഷനിൽ പാക്കറ്റ് എത്താത്ത സമയത്താണ് പാക്കറ്റ് ഡിസ്കാർഡ് ചെയ്യുന്നത്. ഇങ്ങനെയുള്ള സിറ്റുവേഷനിൽ ക്രിയേറ്റ് ചെയ്യുന്ന ICMP മെസ്സേജസ് ആണ് ഡെസ്റ്റിനേഷൻ അൺറീച്ചബിൾ എന്ന് പറയുന്നത്. നെക്സ്റ്റ് വൺ ഈസ് സോഴ്സ് quench. It is a message from one host to another asking the other host to slow down the speed at which the packets are being sent. Sometimes a host is sending a message, the next host which is receiving will be too fast in moving the packets. So the first host needs a second host to slow down because it cannot control the flow of the packets. So in such a case, this type of message is being generated. Source quench is one of the ways to control the packet flow on the internet. So how we can control packet flow in the internet? With the help of an ICMP error message which is known as source quench. Next is time exceeded, also known as TTL, time exceeded. This is an interesting message generated using ICMP. So among the ICMP error messages, one of the interesting error message is known as time exceeded, which is also known as TTL, time exceeded. On the basic level, all the packets transmitted through the internet world will have a TTL value. Whichever packet is moving in the internet will have a TTL value. Now what is TTL? TTL basically stands for time to leave. It is a like parameter which decides how long a packet should leave before it would be discarded. So TTL means time to leave. The name itself specifies how long a packet can leave in a network. That is how long a packet can move around in a network before it can be discarded. That time period is known as TTL value. So for a packet, if a TTL value is exceeded, then the packet will be discarded. So that is an error situation which has to be reported to the source. So in such case, this type of time exceeded ICMP error message will be generated and sent to the source. But why a packet has to be discarded at all? A packet has to be discarded because there will be too many packets roaming over the internet world. So there are several reasons why a packet is getting discarded in a network. There may be duplication of packets. So in such case also duplicate packets should be discarded. Sometimes it might also happen due to bad routing implementation on the network. Due to bad routing implementation, the packets might go into the looping and cause network congestion. So when we take the case of bad route, if a packet has taken bad route, then the packet may even insert inside a loop. So the packet will not reach the destination. In such case also network congestion will also happen, which will not cause other packets to move around. So a network will be moved into a congested state. So in order to avoid all this situation, sometimes a few packets will be discarded. On the other hand, the TTL value keeps on decrementing from one hop to another. So how the TTL value is working? For each and every packet, a TTL value will be there. The TTL value will be decremented each time when it moves from one host to another host. And the TTL value will get decremented. When it reaches 0, the packet, if the packet reaches the destination, it is fine. Otherwise, it will be discarded. Due to looping issue, when the TTL value reaches 0, this ICMP message is generated. So whenever the TTL value reaches 0, this type of ICMP message is generated. Next one is parameter problem. Sometimes problems might not specifically be covered by any ICMP messages. In that case, parameter problem is shown. So whenever an ICMP message is not able to specify the specific problem of a datagram, then this type of parameter problem ICMP error message is generated. And the last one is ICMP redirects. ICMP redirect messages direct a host to deliver the next packet for the same destination IP address to a different router. That is, this type of error message is generated whenever a packet once traveled through a route is not able to reach the destination. Then the destination is informing the source that the packet should take a different route. It should not come like the before route. It should not follow the before route. That is, it should not take the same router. It should follow another router. So such an error, in such a situation, ICMP redirects error messages are generated. So these are the ICMP error messages. Now let us look some important points regarding ICMP error messages. The first important point is that ICMP error message will not be again generated for an ICMP error message. The second point is that ICMP error message will not be generated for each and every fragment of datagram, and there will not be any ICMP error message generated for a multicast address. An ICMP error message will not be generated for special address such as 127.0.0.0 or 0.0.0.0. So these are the important points that has to be kept in mind while creating an ICMP error messages. Now let us look at the ICMP contents of data field for the error messages. How ICMP error message is generated. So this is the original datagram which will have an IP header. Next 8 bytes of data will be there. This 8 bytes of data will have the port numbers as well as the sequence numbers of the packet, and rest of the IP data will contain the original data in the datagram. So this IP header, this datagram is sent from a source to destination, and an error situation has occurred, so wherein which an ICMP packet has to be generated. So how will you create an ICMP packet for this IP datagram? An ICMP header will be added, then inside which the IP header will be encapsulated, and the first 8 bytes of the IP datagram will be encapsulated. This 8 bytes of data will inform the source about the packet's sequence number and as well as the port numbers. Next, this ICMP packet will again be converted into an IP datagram, then only it can be traveled over the network. So for that, this ICMP packet will be encapsulated inside an IP header. So an IP header will be added. Next ICMP header will be there. Next IP header will be there. Next first 8 bytes of original datagram. So this is the ICMP. This is the ICMP packet. This is an encapsulated ICMP packet in an IP datagram. So these are the contents of data field for the error messages.